Wait till 2:30, then we'll resume your session. Yeah. Sir, can we start now?
Yeah, sure. I'm ready.
Yes, sir. Please, over to you, sir.
But I think half of your participants are
Yes.
yet to do. It's only 20.
Yes. So, like, should we wait
So
for
you
1 or
decide.
2 minutes? So, should we
No,
wait for 1 or 2 minutes?
I'm fine. I'm fine with waiting for another 5 minutes. So you have to take a call.
Okay, okay. We'll just wait for 2 minutes more, sir. Then we'll resume.
Okay.
Yeah. Thank you. Pankaj sir?
Yes, I'm here.
Yes, sir. Now I think we can start the session.
Shall we
I'm
start?
sorry for
Okay.
keep you waiting.
Yeah, no problem. Yeah. Okay. So welcome back. Uh, the topic for this session is going to be dummy regression because this is what I'm supposed to cover. Can you see the screen or I have to share again?
You have to share again, yes.
I have to share again. Okay.
Please.
So screen is not visible. Okay, fine. So let me share it again. Now it is visible.
Yes. It's taking a second.
Is it visible now, Dr. Divya?
Yes. Now it is visible, sir.
Visible. Okay, and the
Same
PPT is
screen, yes.
visible.
PPT. Yes. It is visible. Yes, sir.
Okay. All right. So time is limited, so we'll straight away go to dummy regression. Otherwise, I would have done little more on this data. There is a lot we can do on this data. There are several dimensions that we can explore and all. Anyway, so I'm going to dummy regression straight away. So let me show you the full slide so that you can understand it well. Okay. So now can you see this one?
Yes, sir. PPT.
Okay.
Yes. Yeah. Visible.
Okay. So let me first. I'll have to go to the data. I think then only I can discuss this. So let me just go to the data.
Sure, sir.
So I have to fetch data. So I'm going to fetch data. So this time I'm going to fetch data from Excel sheet again. So dummy variable regression data. This data is also with you. Let me see the range I have to import. Just give me a second. Okay, so here is the data with us for dummy regression. So what is the problem? The problem in hand is that we have the data for north, that is one region, south, another region, west, third region. So there are three regions for which we have the data on salary given to the teacher. So these are the salary teachers get. And this is the spending, public spending on the college or school, wherever this salary is considered. So these are the public spending figure. Now, we want to know that is there any significant difference in the salary given in the three regions? So that is the problem. So these kind of problems are very significant and important. Suppose we have the sales data. Let's say sales of fridge, refrigerator. So sales of refrigerator will have something like seasonal, impact. So maybe there will be some season in which it will be the sale will have seasonal impact over there. It will also have regional impact, maybe quarterly impact, like first quarter, second quarter, third quarter, fourth quarter, and which quarter has the significantly different sales. So we may be interested in that. It can also have implication for, let's say, cash in the economy, if you're dealing with monetary data and banking data. So cash withdrawal. So probably cash withdrawal also has significant seasonal pattern. In some of the seasons, the cash withdrawal is very high. Some of the seasons, the cash withdrawal is less. So is there any significant difference in the cash withdrawal? That can be another problem at hand. So any such problems in the regression equation, if you want to accommodate, which has got different categories between which we want to understand the difference. One way to look at the regression here is that, we do the regression between salary and the spending, and we'll say, okay, is there any pattern, like if the government spending on the school is very high, and the salary is also high, so probably we can do correlation, we can do regression and see what is the impact of spending on salary. So that can be one, but that is not going to solve our problem, because our problem is we want to know how significantly the people in the north are being paid in comparison to south or the west, something like that. Is there any significant difference, regional difference? So these kind of problems are of significant importance, and can regression help us in understanding the difference? And there is a very interesting tool that has been there in the regression analysis called the dummy variable regression analysis, which is of great significance. So here, the problem formulation we have done is that we have taken West as a reference dummy. So if there are 3 regions, we are going to create 2 dummies, 3 minus 1. So always remember, the number of dummies we have to create is going to be the segments minus 1. So this is also a tricky question, because sometimes the dummies are also created as many as the segments are. For example, if there are 3 segments here, north, south, west, then we can also create 3 dummies. But if we create 3 dummies, then we don't have to keep intercept in our equation. So our equation will be y is equal to straight away beta 1. There will not be beta 0. So there will be no intercept in the equation. So if you keep intercept, at the same time create 3 dummies, then you will run into a very high amount of autocorrelation, a high amount of multicollinearity, and the regression will collapse. So you cannot actually do that. So there are 2 ways to create dummy. One is that you keep intercept in your equation. So your equation is going to be the same, y is equal to beta 0 plus beta 1 x. The equation will be the same. But in this case, you create dummies minus 1. So that means if there are 3 categories, you create 3 minus 1, 2 dummies. But in case you create 3 dummies out of 3 categories, then your equation will be y is equal to beta 1 x. So there will not be any beta 0 in the equation. So I'll also give you idea how this happens and why this happens. So here in this case, we are starting with the fact that we are creating minus 1 dummy. So, and while creating the dummy, we have to also decide which is our reference dummy. Reference dummy means that this is the category with which we are comparing the others. So here we have kept West as the reference, and then we are comparing with West with South, and the West with North. So here our hypothesis would be, or probably the things that we are looking into is that whether the teachers in North are getting significantly different salary in comparison to West, and whether the teachers in South are getting significantly different salary in comparison to West. So both the comparisons are going to be with the West, and that's why West is called the reference dummy, right? So how the dummy 1 is created? So dummy 1 is called the dummy for the North. So we call it D1, let's say. So there are 2 dummies, so we name it D1, D2. Dummy 1, dummy 2. So how do we create the dummy? So we are creating the dummy for North. So we'll say 1 if North and 0 if otherwise. So that means everything that is pertaining to North will have the value 1. So 1, 1, 1, 1, 1 everywhere. And the rest of the values are going to be 0. So you can see the value for the West and the value for the South is all 0. And it's only the North which gets 1, 1, 1, 1. So this is the dummy for North, and we call it D1. Is that clear to everybody? Any question on dummy? So D2, how D2 is created? D2 is for south, right? So we are creating dummy for the second category, that is south. So this means 1 if south and 0 otherwise. So that means north is going to be 0, south is going to be 1, all south, and then again west is going to be 0. So if there are 4 categories, then we are creating 4 minus 1 dummies. So D1, D2, D3, and this will be the process followed for creating all dummies. Is that clear? Yeah, any question on formulation of dummies?
So there is one doubt. If we'll be having D3, so we'll be marking north as 0, south as 0, and west as 1, right?
Yeah, if suppose D3 is created, then
Yes.
whichever reference you are creating it for example, you are creating a dummy for west. So all west will be
Right.
1 and rest of them will be 0.
And
so you're right.
Remaining will be 0. Fine.
Yeah.
Okay, sir.
Yeah.
So maximum
but
how
always,
many dummies? Sorry,
yeah,
how
please,
many
please
dummies
go ahead.
can we create? How many dummies can we? How many groups can we have, sir?
Any number of dummies you can create.
Okay.
But the principle that you have to keep in mind is that number of segment for which you are creating a dummy, number of parts you are creating a dummy for, the number of dummy will be always -1, right?
Yes, sir.
So if you have 5 categories and you want to see the difference, in all 5 categories, then you have to create 4 dummies. And one dummy will be one area will be called reference dummy. So reference dummy has to be identified, and in comparison to that, the other dummies have to be created. Is that clear? Okay. So I also made one more point, so I'm reiterating that point again. It's a very critical point. If you are creating -1 dummies, number of dummies -1 means 3 categories and 2 dummies, then your equation remains unchanged. Y is equal to beta 0 plus beta 1 x or dummies whatsoever. But if you are creating 3 out of 3 dummies, if there are 3 categories and 3 dummies, then your equation will not have the intercept. You have to remove the intercept from your equation. So your equation will be y is equal to straight away start from beta 1, right? I hope you understand the difference between the 2 equations. Then both are linear equations. So y is equal to beta 0 plus beta 1 x, one equation. Another is y is equal to no beta 0, y is equal to beta 1 x. So what is the difference between the two? The difference between the two is that the second equation without intercept will have origin from 0.
Yeah.
It will not have any intercept. So it will always originate from 0. So therefore, in financial analysis, when you're talking about short-term trend and the long-term trend for anything, any variable like savings, short-term saving, long-term saving, consumption, short-term consumption, long-term consumption. There are many hypotheses you can see, like Friedman's permanent income hypothesis if you want to draw, or if you want to work on Modigliani's model, all these kind of things that if you start building, then you have to differentiate between short-term analysis and the long-term analysis. The short-term analysis will have intercept, and the best fit in the long-term is without intercept. So all over the world, in many countries where the econometrics are being looked at very intensively, you will find that people have actually started dropping the intercept in their equation. They are not actually taking intercept in their equation. They're saying it doesn't make any sense to keep intercept in the equation, because that's not how people in actuality behave. So I mean, there are many debates, but we are going by conventions in India. So our equation is always y is equal to beta 0 plus beta 1 x, right? So if you have more time, we can discuss on the merit and demerit of these two approaches. But even without intercept, the equations can be run. So this is what. So I'm going to now this one. Let me show you this page little more clearly so that you can understand. Yeah. So what I'm going to do is I'm going to take something like, let me also make it more clear to you. So can you see this? Now you can see it very clearly, right? So we'll say the reference dummy is west. We have already discussed. Dummy for the north is D1, 1 if north, 0 if otherwise. So here the equation is y is equal to beta 0 plus beta 1 dummy 1 plus beta 2 dummy 2, and this is error terms. So this is a generalized equation, right? So when we are creating two dummies, so this is a generalized equation because there are two dummies created and E. Here in this equation, we have not considered any X because we want to just see the difference in salary in the three regions. That is our concern. But if we really want to also see the impact of the covariate, and the covariate is spending. So dummy along with covariate. So your question is that, question could be that, can we use some covariate like X, Y, Z variable along with the dummy? Then we'll see it in the next exercise. So how covariate can be used and what is the impact of covariate. But here in this first exercise, we are not taking any covariate. So X is ruled out. There is no X in this. So there is only Y and two dummies, which we have created out of this data. So this is the equation, generalized equation. Now we come to north. So if you have to calculate the average for the north, so we have the Y value, that is expected value of Y, if or when the dummy 1 is equal to 1, because we are talking about north. So D1 actually represents north. So if the dummy 1 is 1, dummy 1 is 1 and dummy 2 is 0, that means we are not talking about south. We are just talking about north. So in this equation, if we take the assumption that D1 is equal to 1 and D2 is equal to 0, because we are talking about the north. So expected value of Y equation would be that average of Y is going to be beta 0 plus beta 1. This means that if you take the intercept value and add into it the beta value of D1, these two values, if you add together, this will give you the average for the north. So you can find out the average salary of the north by using this equation, beta 0 plus beta 1. So that is 1. And when you look at the dummy for the south, that is the dummy 2, here the dummy is created 1 if south and 0 if otherwise. So the average for the south, that is expected value of Y, is D1 is 0 and D2 is 1. So that is the assumption because we are talking about south. So your expected value of Y is going to be equal to beta 0, that is the intercept, plus the beta coefficient of D2, that is here. If I just let me take the anyway, it's not coming. So let me just take this laser printing, laser one. So here you can see, beta 0 plus beta 2, and beta 2 is the intercept of D2. Sorry, the coefficient or parameter of D2, right? So beta 0 plus B1 representing north, beta 0 plus B2 representing south. So that is how it is going to happen. So the natural question is that because we have only two dummies, so what will represent west? The west is the reference dummy. So average for the west is going to be like this. So expected value of the Y for west is going to be when the D1 is equal to 0 and D2 also is going to be 0, because west is a reference dummy. So you put both at 0, then the average of the west is equal to the intercept, the value of the intercept. So this is the difference, that if you take the intercept, then the intercept itself becomes the average for the reference. So you don't have to create dummy for the reference. And that is why 3 minus 1, because you are keeping intercept. But if you don't keep intercept, then you have to create dummy for the reference. Is that clear? ठीक है ना?
Yes, sir.
Okay. So let me go back to this one. So I'm going to give you the average first. So I'm taking all north together. Let's say, first let's have a look at the average, how they look like. So this is north, the data for the north, all salary for the north. Then I'm copying the salary for the south. Pasting here. These are the salaries for the south. Now I'm copying the salaries for the west. Let me also write down. So this is the variable north, south, west. So these are the salaries for north, south, west. Now I go to analyze, go to descriptive, go to descriptive frequency, and then I'm saying that okay, give me average of all three. So I don't want a standard deviation, minimum, maximum. I don't want. I want only mean. So I clicked mean and I said okay. So these are the average for all three. So this is the average we got. So keep this average in mind. North 24,701, south 22,894, west 26,964. So I have noted down these averages over here. You can see here. Did you see this? So this is the average for the north, average for the south, average for the west. And this I have kept it for you. So what is the hypothesis here? So these are the salary that the three different regions teachers are getting. So seemingly, if you look at the number 24, 22, and 26,000, they are very different. So what is the hypothesis here that we are trying to test? We are trying to test the hypothesis that the average of the north, whether the average of the north, the null hypothesis would be the average of the north is equal to the average of the south is equal to the average of the west, is the null hypothesis. Means all three are the same, statistically speaking. So when we say statistically speaking, what does it mean? It means that we have taken this data from a sample of teachers, right? This is the result of one given sample. So if I change my sample from south, north, and west, will I get the same number? So that's what we are trying to test. So a statistically significant result means that they will be the same. So if I change the sample, we'll get 24,000 for north, 22,000 for south, 26,000 for west, even if I change my sample. But if I change my sample and I get a different result for north, south, west, this means this number difference is insignificant. It's not actually significant. So null hypothesis comes from there. So they are the same. And what we are trying to test through this regression equation is whether they are significantly different or not. Right? So this is the alternative hypothesis we are working on. Now I'm going back to the data again. Go to analyze, go to regression, go to linear. It's a simple regression that we have to run. Right? It's a very simple regression we have to run. So we are trying to explain the salary is the dependent, and then we have the two dummy variables as independent. Right? So that's the equation. Equation was y is equal to beta 0 plus beta 1 dummy 1, beta 2 dummy 2. That's what the equation was. And we say, okay, where is the result? So let's not describe this ANOVA and model summary. First, we focus on coefficient because we have to understand the concept of dummy first. So here you see the constant, that is beta 0 value is how much? 26158. And D1 value is minus 1,734 and D2 is minus 3,264. So let's go back to calculations. Let me, from the current slides, and let me take. No, sorry. So just wait for a while. Yeah, so this is what I want. Slide. Yeah. So results. So results are beta 0 value is 26158. Beta 1 is, we have already seen minus 1734. Beta 2 is minus 3264. That's what the result was. And what is the average for the north? Beta 0 plus beta 1. We have already seen this, right? Why this is going to be beta 0 plus beta 1. So beta 0 value is 26158. And beta 1 value is minus 1734. So it is equal to 24424, right? 24424. And interestingly, what was the average of north? 24424, you see. And we calculated it from simple method, and we got 24424 was the salary in the north. And so what is the salary, average salary of the south? So as per the equation, the average of the salary of the south will be beta 0 plus beta 2, right? So beta 0 is 26158 and beta 2 is minus 3264. So it comes to 22,894. And what was the average, simple average of south? 22,894, right? That's the beauty of this whole calculation, you can see. And then you can see where from we got this average salary of the West. The average salary of the West is beta 0. It's as simple as it is. And what is the value of beta 0? 26,158. You got it? Did you get this now?
Yes, sir.
Yeah, okay. Now we go back to the result. So you got the average. So question is whether these averages are significant or not. So in dummy regression, these coefficients, that is beta coefficients, are called differential beta. They are not called only beta. So there is a difference between simple regression equations beta and the dummy regressions beta. The simple regressions beta is called beta, which is the rate of change in or slope of the curve. But here it is not. In dummy regression, the betas are called differential beta. So why it is called differential beta? Differential beta because the difference in the cell, they represents the difference in the value in this particular category. That means if D1 is created for north, then it says that the difference in the salary of north from the west is about minus 1734. That means on average, people in north are getting 1,734 less than the west teachers in the west. That's what it says. This beta says. And this is the only interpretation of this beta. So that means this beta is a differential beta. Likewise, the differential beta for the south is minus 3,264. This says that on average, the teachers in south, they are getting 3,264 less than the teachers in the west. So that is what these figures are to be interpreted for. So there is no other interpretation of these figures. So these dummy betas are called differential betas. Is it understood? Differential beta, is it clear to everybody?
Yes, sir, it is clear.
Okay. And now the hypothesis testing. Hypothesis testing is about the fact whether if suppose north people are getting 1,734 less than the west, then is this difference significant or insignificant? So we go to looking at the p-value. And here we find that the p-value is 0.233. This means that if I change the sample, there is 23.3% chances that I will not get the same difference. right? So this means it is more than 5%, you know, it's less than 95% level of significance, more than 5% error. So I'm not taking it as significant. So we'll say that, yes, there is a difference. North people are getting some less, on average, less than the South, but this difference is not significant because it is just because of the sample that the difference appears. So if I change the sample, probably will not get the same difference, right? So when it comes to when it comes to South, the p-value is 0.034, that is far less than 5%, that is 0.05. So this means it's significant. So what we can say is that on average, the South people are getting 3,264 less than the West teachers, and this difference is significant. So this means the South is discriminated against the other regions and is significantly getting differently lesser salary in South in comparison to the West, right? So that's the conclusion that we can have from this data. Is this clear to all of you? Any question on that? That's the simple interpretation. So, you know, dummy regression is maybe a slightly complicated or difficult to understand, but it's so simple to operate and simple to interpret.
So what will we say, like which hypothesis is accepted and which one is rejected? How we'll write that?
Okay, so for the North category, for the category North, the null hypothesis is accepted, that there is no significant difference in salary between West and South, West and North. And for the West, the null hypothesis is rejected and alternative accepted, that there is significant difference in the salary between North and the West. Is that clear?
Yes, sir. Thank you.
Okay.
Sir,
Yeah.
Sir, I have.
can you repeat once again the explanation of the hypothesis analysis once more?
Okay, sure. So the beta coefficients are called differential beta. That is the first thing we have to understand. And why it is called differential is that they represent the difference between the reference category and the category for which we are talking about. So here the reference category is West, and the differential beta for North is minus 1,734. So what it says is that the teachers on average in North are getting 1,734 less in comparison to West. That's what it says. This beta says, right? So the question hypothesis here is this difference significant or insignificant? So what does it mean when we say this difference is significant? Or what does it mean when we say this difference is insignificant? The statistical significance is about the fact that this difference is actually estimated difference is based on the sample that we have taken, right? So what are the probability that if I change my sample, I will get the same difference? Unless I get the same difference, even if I change my sample, it cannot be taken as significant result, right? Cannot be a valid result. And therefore, for that, we look at p-value. So in the last column, if you see SIG, the value under that, the SIG is significance. So it's representing the p-value. So the p-value is 0.233. So what is the rule of the thumb for rejecting the null hypothesis? Rejecting the null hypothesis is that the p-value should be equal to or less than 0.05. That should not be more than 5%. So it's 5% level of significance that you talk about. Here it is, the p-value is 23.3%. That means in layman's language or in simple words, we can say that if I change my sample, there are 23.3% chances that I will get a different result or different differential, which this beta is actually representing. This beta is representing 1700 differential, but if I change the sample, will I get the 1700 differential only, or will I get different differential. So the result says you will get a different differential. So this means you cannot actually take this difference as significant. You cannot predict or you can generalize on the basis of this difference for the population. You cannot generalize. So that means it's insignificant. Insignificant means you are actually accepting the null hypothesis that the salary of the North and the South are the same. They are not different.
That's all. Thank you.
Yeah. So and other way around for the South, because the p value is less. Yeah. Sachin ji kuch पूछ रहे थे आप. Okay. So
No, sir, it's okay from my side. I got.
Yeah, okay. ठीक है, fine.
Sir, can I ask one question?
Oh, please go ahead.
Sir, on this particular basis, we can only compare North and South with the West. We cannot compare North and South.
No.
Okay.
So there has to be a reference dummy, and you have to compare with that reference dummy.
Yeah.
Okay, fine. Now interactive dummy. So what happens if you take a covariate? Because
Sir,
quite often it's not
sorry
just.
to interrupt, but we can, if we can have the base of North and South only, then we can compare, right?
Yeah, so you can compare, but you can make the North as the reference dummy.
If we make the North as the reference dummy, then we can compare between North and South, or
with the
South
North
as the reference dummy, then vice versa can be possible.
Absolutely. So it depends on how you select the reference.
Done. Thank you, sir.
Say, for example, in quarterly sales. So you know that, what sales are you talking about? Are you talking about ice cream sale, or are you talking about clothes sales? So, you know which quarter is to be taken as a reference, from which quarter you want to compare. You can do that. Yeah. So if you take a covariate, that is probably we say that the difference in salary in these three regions are also because of the spending. Probably spending is higher in some region, spending is lower in some region. So salary is related to spending. So we cannot ignore spending by the government on these schools. So let's also take X, that is covariate, in the model. So when you take covariate in the model, then your equation becomes y is equal to beta 0, beta 1 D1, beta 2 D2, that is the two usual dummies, and plus beta 3 you have to add for the covariate. So beta 3 X, and here X is your spending. So there is one variable that you are actually inserting into it. So let's have a look at the data. So you have the salary as dependent, and here spending as covariate, right? And then you have two dummies. So you're going to use all three in your regression. So let's see if we do that, does the result changes? So we go to linear. Everything will remain the same. All we have to do is to add spending as independent variable. So you have now two dummies plus one is spending, a covariate, right? And then we'll say, okay. So look at the result now. Can you interpret this result? Some of you can try and interpret. Can you interpret the result of D1? Yeah, anyone who would like to try? After considering the covariate, what is the result now? Is the same result or result has changed?
So the result got changed. Earlier, beta 1 was insignificant. I mean, vice versa हो गया.
उलट हो गया पूरा.
हाँ.
पहले नॉर्थ का इंसिग्निफिकेंट आ रहा था, साउथ का सिग्निफिकेंट आ रहा था.
हाँ, अब उल्टा हो गया.
साउथ का इंसिग्निफिकेंट है और नॉर्थ का सिग्निफिकेंट हो गया.
हाँ.
राइट. और नॉर्थ का भी जो सिग्निफिकेंट है वो बिल्कुल ही मार्जिन पर है,
0.04. एक ये है.
तो एनीवे, बट अगर उसको सिग्निफिकेंट मान भी लेते हैं तो फाइन. सो given the public spending, or looking at the public spending and taking that into consideration, we find that the difference in the average salary between West and the North is significant, while the West and the South is insignificant. So that's the result.
So West please, once again.
Yeah. So given the public spending being done by the government on these schools, we find that the difference in average salary between West and North is significant, while the difference in salary between West and South is insignificant.
Insignificant.
So ये result आया आपके साथ. Is that clear?
Yes, sir.
ठीक. Good. So I'm now fetching another data to give you another application of dummy. So this is one application of dummy. A dummy has got several applications actually. You can also use it for, for finding out or removing the seasonality from your data. Because in time series, we have to take care of the element of time series, like you have to look at the trend, you have to look at the seasonality, you have to remove them, and then only you can use the data. So through dummy, you can remove seasonality very well. So this is another interesting application I'm going to give you. So let me see the data. So first, let me see where will the data be. So I'm going to the Excel sheet, dummy variable. These data are all with you because I have already shared. Now this data is in sheet number 2. So I'm going to fetch data from sheet 2, not sheet 1. So A1 to D27. So these are, I've already noted it down a prior. That's why I know what is the data I have to fetch. But if you're starting afresh, you have to note down these numbers from where to where you need the data and which sheet. So this is the data. You have the data of year, then you have the data for savings, right? So these are the savings in the country, and then you have the income data. Now here the problem that I am taking up is that there is some kind of difference I can observe in the saving pattern in the country. Like there was a cutoff year after which, or there was an event after which things have changed. For example, if you're interested in knowing what happened before COVID and after COVID on certain counts, let's say, is the saving habit of people changed significantly before COVID in comparison to before COVID? That may be a very interesting analysis. After a year, you take the data of people and then check कि COVID के पहले क्या था, अभी क्या है? Things like that. There are many comparisons that you would like to do. So here I'm trying to do that. So the whole year is divided into 2 parts, and the rationale for selecting the year before and after which you want to compare will depend upon the theory or insight, your own understanding, right? So here in this case, I'm going to give you a little more idea here, and then we'll proceed further. So I'll come for the with the data, in a while. First, let me make you understand this. So what I'm going to tell you is the alternative of Chow test. There is a Chow test in econometrics we do. The Chow test does the same thing. So what it does is that it will take out the regression on the data before the event. It will take out the regression on the data after the event, and then they will apply some kind of formula and things to find out the difference between the two. That's what the Chow test does. Dummy is a good substitute of Chow test. It makes the things very easy for us because it doesn't calculate 2 regressions. It actually combines the 2 data together and then calculate 1 single regression. And with a single regression, you are able to understand what is the difference between the period before and period after, right? So it's a beautiful application, you can see. So what happens is that there are 4 kind of scenarios that can emerge when you are interpreting this kind of thing. This is the first scenario, right? So in the first scenario, you can see that you have a coincidental regression. That means if alpha represents the intercept and the other parameters of one equation, one regression before the cutoff, and beta represents the parameters of the regression after the event, then here we find that the intercept of both the regression equations are the same, and the slope of both the regression equations are the same. So if this happens, this is a pure coincidental regression. This means that the slope of the two events or two periods are the same, and the intercepts of the two periods are also the same. That means there has been absolutely no change whatsoever before the event and after the event. So on some kind of things, if you are checking the data, and if you find this happening, this means there is no difference in the behavior of the variable before and after. So it's called the coincidental regression. But if you get this kind of event where the slopes are the same, you can see the slopes are the same, but the intercepts are different, right? So intercepts of the two periods are different, but the slopes are the same, right? So this means that this is a parallel regression. It's called the parallel regression. That means the behavior has not changed, though the quantum of impact has changed. Quantum has changed. So for example, the saving behavior has not changed. In this case, let's say, if we get the parallel equation, that means the saving behavior of people has not changed. People are saving only in the same pattern as they were saving earlier, but it's only the quantum of saving that has changed. So that's the difference between intercept and the slope, right? So it's called the parallel regression. This is another scenario where the intercept has not changed, right? But the slope has changed. So the regression equation is moving in the two different directions, before and after, right? So before equation is different, the after equation is different. So it's called the concurrent regression. So if concurrent scenario is seen, that means the behavior of people have changed, but it's not the quantum that has changed. The saving is the same. Saving, people are doing the saving in the similar fashion or similar quantity, but their fundamental behavior has not changed. Now, this is called the dissimilar regression, which will give you a clear-cut idea about if the if things are absolutely different in two different two periods, before and after. This is called dissimilar regression. Here, the intercept and the slope both are different, right? So what we check for is whether the intercepts are different and whether the slopes are different, right? So that's what we check for. How do we create the equation in dummy? So y is equal to, so t, because it's a time frame, so yt is equal to alpha 0. Alpha 0 means we are talking about one period. There are two periods. The whole period is divided into two periods. There is a cutoff here, right? So period 1, alpha 0 and alpha 1, these two represents the intercept and the slope of period 1. Beta represents the period 2, which is a reference period. So because it's a reference period, so we have the beta 1 xt, and the beta 2, there is an interaction dummy. This is called the interaction dummy, interactive dummy. We call it dx is called interactive dummy. This means the multiplication of dummy and the variable we do, and then we create a variable out of it. So this is beta and then e. So here in our case, y represents savings, x represents income, t represents time, and the dummy created is 1 for observations in 1982 to 1985 and 0 otherwise. That means that is the observations in 1970 to 1981. So the whole period is divided into two parts, 1970 to 1981 and 82 to 95. And we have taken 1982 to 95 as the reference period, that is post-event is the reference period, and we compare it with the pre-event. And the cutoff year is 1981, 81, 82. That is the cutoff year, right? So the data is divided into two periods and the dummy is created, right? For the comparison of the two periods. Any question from this theoretical part? Then I move to the data.
Sir, only one question. Herein we don't have to look for beta 0, right? Because alpha 0 is representing beta 0.
No, beta 0 we don't have to, because the second equation is for the reference period.
Beta 1 xt plus beta 2 dt xt, right?
Yeah, absolutely. And then second period, we are adding this interactive dummy. So this becomes actually a representative of intercept. But these are the two intercepts.
Having the coefficients for coefficient value for beta 1, beta 2, as well as alpha 0, alpha 1?
Yes, we will have, yes.
Okay,
We'll
fine.
have
Sir.
values for all these. Yeah. Any more
Sir,
question?
Sir, in this we have taken the reference time period 82 to 95.
Yes.
And for
That is,
this we are taking d is equal to 1, whereas in previous one, for the reference category we have the 0 value.
yeah, sure. So the data is available from 1970 to 1995, right? And 80-81 was the cutoff year. So we divided this data into two periods, and we said 1970 to 81, that is pre-event, and 82 to 95 post-event. For example, budget. So if you see some major announcement in budget, let's say last year, there was a major announcement in budget, and the analysts, as an analyst, you said that, oh, this provision is going to change the behavior of people in terms of saving, or in terms of, let's say, tax saving, or in terms of expenditure, anything that, this announcement is going to change things in a big way. So you have taken that budget year as the cutoff, and before that and after that for certain variable. So, the second period, the after one, is taken as the reference dummy. So it is 1. And the previous one is considered as 1 when we are creating the dummy. So when I go to the data, you will be able to understand how this has been created. So you can see this dummy. So this is from 1970 onwards till 1981 is 0. And after 81, it is all 1. So this is how the dummy is created. Is that clear? Here, we also need one more variable that is called the interactive dummy, dx. But as of now, this data does not have dx. So we have to create dx, right? So what is x? So x over here is saving. We are talking about behavior of saving. So we go to transform, compute variable, and then we say, oh, give me dx. And dx is dummy multiplied with savings, right? That's simple dx, right? This is a calculation for dx. We'll say okay. And when we go to see the data, dx is already created. So for 0, 0 is going to be 0, and this one. Is this okay? Now we go to analyze, regression, linear. We are explaining saving on the basis of dummy and dx, right? And then say okay. So here is the result. What is your interpretation now? Because the dummies are here, the dummy coefficients are the differential coefficients, but the interactive dummy represents the differential beta. So you have to remember that, because here we have to look at two things. One, whether the intercepts are different and significantly different, or whether the slopes are significantly different, because it depends on which one is significantly different, or both are significantly different, because there can be 4 different scenarios, right? We have already seen. And depending upon the scenario that is emerging, we have the interpretation. So the dummy is actually representing the differential intercept, and the interactive beta is representing the differential slope. So here we find that the dummy is significant. Sorry, dummy is not significant, and interactive beta is significant, right? So differential beta is significant, but differential slope is not significant. So what is the interpretation? Go ahead, please.
Sir, change in the behavior.
Change in the behavior, yeah, of course. So the quantum of saving has not changed between the two periods, but the behavior of saving has changed quite a lot. That is the conclusion. So what kind of regression, what kind of difference we have seen here? What kind of situation has emerged out of these four?
Concurrent.
Is the concurrent situation, yes. This is the concurrent situation that we have. Is that clear to all of you, or is there any more question on that? What is emerging is a concurrent situation. ठीक है ये आगे बढ़ूं? Should I move ahead?
Yes, sir. Yes, sir.
Okay, good. Fine. So let me see what is there. ये थोड़ा सा और complicated लग रहा है. I don't know. I have brought so many complications for you. Okay. क्या हो गया? Current slide. So I think I have to take this. Yeah. Okay. So if you look at here, the average savings for 1977-81 with the same logic, if you try to calculate expected Y, that is expected saving, average saving, you have to keep D as 0 for, because we are calculating 70-81. So the dummy is 0 and XT. So if you put that in the equation, you get alpha 0 plus beta 1 XT. That's the equation you're going to get. So if you put values, the value of alpha 0, value of beta, you get this equation. So if you divide the period into 2 and run the regression equation separately, right, for 70-81 and 82-85, you will get this equation after running, right? But from the differential beta and dummy regression that you have calculated, if you just put the values here, you will get the same result. So it is a substitute of two different regression equations that you will be calculating in Chow test, right? So average saving for 82-95, which is a reference. So expected YT means DT has to be 1 and XT. So you have you use this kind of assumption, and then you are left with alpha 0 plus alpha 1, beta 1 XT, beta 2 X2 XT, right? So you have alpha 0 plus alpha 1, and then beta plus beta 2 XT. So if you look at the second equation, so these two together actually form the differential slope, and these two together forms the differential. These two together forms the differential intercept, and these two together forms the differential slope. And that's why we say the interactive dummies beta, whatever you get, is a differential beta. So we call it alpha is differential intercept, and here beta is differential slope. So, and this is also known as slope drifter, because the significance of differential slope, if it is significant, it actually drifts the slope. This means that the slope of the regression after the event has actually drifted away. So is the case we see in the concurrent, right? So in the case of concurrent, you will find this part as significant. In the case of different equation, you will see this part significant, but in the case of parallel equation, you will not find this part as significant. This part will not come significant. If this does not come significant, that means it's not a concurrent situation, neither it is a different situation. It can be either parallel or it can be, the first one. So you have the estimated equation over here. Y is equal to 1.0016, 152.5479 dt, 0.080 xt, and minus 0.065 dt xt. That's what the equation has emerged after regression running. So what is the saving for this period? So equation is this, 1.0616, 0.08 xt. So this one is your equation, the equation for the period 70 to 81. So now if you want to really check this result, you take the data out, this part data separately, and run the regression. simple regression, and you'll find this equation. You'll get this equation over there, right? And for the second period, this is what the calculation is, and you will get this one, this equation, the two equations, right? So you don't have to calculate the two separate equations. You get the two equations from a single equation in differential in dummy calculations, right? And you also get the interpretation. So by one single regression equation, you also come to know the result. Here in Chow test, you have to calculate both the regression equation and then go for some other test to see the result. I don't know those tests because I've just heard about Chow test. I've never experimented with Chow test. So you may have to go through some other process to understand what is happening, what is the final result, right? So that's why it is called the alternative to Chow test. Any question on this? It looks like that my slides are over. If there is any question here, if not, then we can go back again to this. Yeah. So now about 15 minutes left. So I'm done with all the topics that is given to me. Now, if you want me to do something extra for you, I can show you something. Otherwise, if you want to ask some questions, interact, give your feedback, you're most welcome.
Participants can ask their queries from sir. You can ask your queries from either of his session.
I hope you really learned something in this session. Generally, a short session of 1, 2, 3 sessions does not yield into much learning, but I tried to make it more friendly so that you can learn a little bit at least. So did you learn something from the session?
Yes, sir, of course. The only point is we even have to get hands-on practice on the data so that to have confidence, yes, that we had learned it.
Oh,
As such,
absolutely. So please go ahead, please.
Any other participant?
Yeah, so generally when I conduct this kind of workshop, I do it hands-on because the same data set is handled by the participants.
I request all other participants kindly mute themselves. Dipti ma'am, you please mute them. This is the drawback of sir online education. Yes, sir.
Yeah, Dr. Sachin. So it's not
Sir, you're mute.
He can, Prabhat sir, you have to do it by yourself, yes.
okay, done. So what I was saying is that the problem is not in the technology. The problem is how we deal with it.
Right.
Yes. Right, sir.
So I'm announcing once again, if participants are having any queries related with the session, so I think it is the apt time to, clarify your queries with the sir.
Sir, I want to ask because this dummy variable thing, in case you can suggest us by giving a few examples that, what kind of research papers, especially finance people, can actually use them, because you might have come across research papers and all, so that, we can have some idea where to use this learning.
So is the question complete?
Yeah, I don't know. It was mentioning host has muted you. So I just want to get some ideas that, where, in what kind of researches and all that, where we can use it, because you might have come across research papers, so that we can find similar research papers. And
Especially you will have to find out what kind of data you are handling, whether dummy variable is really suitable over there or not. But in my research, I have used it quite extensively. Say, for example, one of the work that I did was in the field of tourism. So I'm not into financial data handling, but tourism, I did some research. So in tourism, I use this dummy to understand the impact of different kind of visitors who are coming. So these kind of impact you cannot assess through simple regression. So dummy actually comes very handy. So anything which is very qualitatively affecting your data and you're not able to understand how regression can help you, then dummy helps you. There are applications of dummy. I showed you two applications. One is the simple finding out the difference, differential, differences, comparing the three categories. Another, I gave you the example of how the pre-event and the post-event can be compared using dummy. So there are other, other applications of dummy as well. So I'll suggest that you go to Damodar Gujarati and read the book. It's a very lucid exposition of different applications of dummy is given in Damodar Gujarati. So quite often I refer to this book, and I also learned doing things using Damodar Gujarati. So it can be a very good reference book for all of you.
Is dummy essentially 0 and 1 only? It's 0 and 1.
Is 0 and 1, yes. Dummy is created by using 0 and 1.
Sir, there is a problem sometimes we face in dummy trap. Sometimes suppose there are 12 years are there. We use 11 years as dummy, and then it becomes impossible to use the last year. And that's a dummy trap we'll sometimes face. So, so how to handle that kind of situations?
Yeah, dummy trap is, I don't know. Dummy trap is basically when you create, let's say 3 out of 3 dummies, three categories out of three dummies out of 3 categories,
yes,
and at the same time you're also using the intercept in your equation. Then
yes,
you have a dummy trap. Then you have a dummy trap. So the way to check is that always follow the rule 3 minus 1 or n minus 1.
N minus 1, yes.
So that actually helps. A second,
So
if you want
simple
to
way to n minus 1 is the way, sir, out. I think 12 years, so n minus way. But in case of 2, there will be no problem. The reference will be 1. That is the 1 will take the reference. And for 0, there is alpha where will be 0, no problem.
Okay. But if that kind of problem arises, then don't use intercept.
Okay.
Remove intercept. Then you will not be in the trap. Okay. Sachin ji.
Any other participant has any question? No.
All right. So let me just, we have 10 minutes more. So let me use one more data and show you something interesting, which you may be interested in. And this is not related to regression and correlation. It's related to non-parametric, how you use non-parametric measures, right? So let me fetch the data first. And I'm going to use a very big data set. So you can see how high, this kind of data set can be used. You see here, there are so many variables, a socioeconomic survey data. I have also shared this data with all of you. And there are 6,400 responses, you can see. So it's a huge data. So I'm going to take one single problem and then try to discuss with you. So we go to analyze, let's say descriptive statistics. We go to, let's say crosstab. So I'm going to make you understand how crosstab works. We go to crosstab and I'm picking up two variables, let's say household income. So I've taken household income, and then I'm also taking something like, used by the customers. I'm taking this specific instrument called PDA. PDA means personal digital assistance. So people who are using any kind of bot or AI based instruments. Then we go to statistics. So I'm not checking anything here. Sales, of course, the observed frequency. I just want to see the observed frequency first. So there's a table you got. It's called the crosstab table. Crosstab table means you have the income category under $25, $25 to $49, $50 to $74, 75 and plus. These are the categories, right? And then you have the information like whether how many of them are not using, how many of them are using. And the total sample is 6,400. Now, can I ask you the question, can you make out something from this table? Can you give some insight from looking at this table? Can you interpret this table and give me some insight about the relationship between income and the purchase?
Sir, what is PDA?
PDA is personal digital assistance. That means anything which is intelligent device that you use, maybe AI based or some other, like Alexa, something of this sort.
So can you explain the procedure again? Because I haven't got the same table. The second one I haven't got. I think I've missed out on some steps.
Okay, analyze, descriptive statistics, then go to crosstab. Right. So I've taken income in the row and owns PDA in column. But you can exchange also. So it will be shown this side, the other ones will be shown other side. So it doesn't matter. Right. And I did not check anything in statistics. I did not check anything here except the observed frequency. That means give me the raw frequency. And then said, okay. So here the interpretation is that if you look at the people who are using it, so 191 using it in $25, under $25 category. If you move on in the income, the number increased, then again number decreased, and then again number increased. So it's inconclusive. We cannot say anything about it, right? But it has to be with respect to the total people who were asked. So if you look at here, 1,174 people were asked. Here, 2,388 people were asked. So it is not the absolute number that will represent the relationship between the two variables, but it's the relative number that will actually give us some idea. So in order to find out the relative number, we go back again to the table, creation, we go to cell, and then we say, okay, why don't you give me percentage row wise? So I just checked percentage row and then clicked it. So you see how beautiful table is created in front of us. And here you can see that if I move higher and higher in the income category, we find that the percentage of people using 16.3%, 19%, 20%, 25%, as the as the income increases, the percentage of people using this device increases. It's very simple. So can we say that, yes, income is the main factor affecting the purchase of PDA as a researcher?
Yeah, there is a direct relationship.
Yeah, there may be direct relationship. Or do you think that there is a direct relationship? Maybe or
Maybe.
Maybe, yes. Of course, yes, maybe. It has to be maybe. You cannot just say as a researcher that there is. Why it is maybe? Because it's a sample. I have not gone for inferential testing, right? Yeah. So unless I do the inferential testing, I cannot be sure that it is, right? So what is the test I should conduct to know the relationship between purchase and income? I cannot go for correlation. I cannot go for regression, right? So all I have to do is to go for chi-square test, which is a very universal kind of, so we go to descriptive, we go to crosstab, go to statistics, and we say, okay, we check the chi-square. So give us chi-square test. We say, okay, that's as simple as it is. And then you get the chi-square table here, right? So you say Pearson chi-square is significant. Pearson chi-square is significant. These are also likelihood ratio is calculated based on the likelihood method. Linear by linear association is irrelevant because there is no correlation that can be established. So it's a spurious one. So we have to look at the first one, which is Pearson chi-square. And I hope you know how chi-square is calculated. So chi-square is significant. Yeah. So chi-square is significant. So this means that there is a significant relationship between the two. That's what we are saying, right? So it's a non-parametric test that we apply. But I'm going to give a twist here in this whole research, right? So just see the twist, and you will like it. This researcher who was doing this relationship between the income and purchase also thought that we are talking about digital assistance. So probably education also must have played an important role in it, right? So what he did was that he took the data for education, levels of education, right? And he put it here as a layer variable. Layer variable means you have the given scenario of education. And if the education of an individual is given, then how the relationship between income and purchase is established. That's what he did, right? And just see the result. So let's forget about the table and all. Let's go to the chi-square test. So what he found was that in the category of education like did not complete high school, the chi-square is insignificant. In the high school category, the chi-square is insignificant. Some college, chi-square is insignificant. College degree, significant. Postgraduate, insignificant. So he was really perplexed. He said, in the first go, income was absolutely the significant variable for purchase. And here, the moment I started looking at education as a layer variable, means considering the level of education for them, given the education level, the income actually is not a layer variable. Income actually is not a variable in purchase. It's turned out to be that it is not a variable in purchase. So, as a researcher, can you tell me why this is so? Why this is so? In the statistical result is not supporting the previous finding. Why? Okay, so we are running out of time. So I'll just go again to descriptive, crosstab, right? And just see what I'm doing. All right. Can you tell me what did I do? Any of you?
Sir, layered में आपने income डाल दिया है and you considered base as the level of education.
हाँ बिल्कुल. So hypothesis को read करिए. पहले hypothesis था मेरा या research question जो भी हो.
PDA, income and अब बन गया level of education and this PDA.
हाँ बिल्कुल. So अब जो hypothesis बना वो ये बना कि given the income level of people, do education lead to purchase? पहले क्या था? Given the education of people, do income lead to purchase? Right? So I just changed the variable. Look at the result. So fascinating. All of them are significant. Now the question is that why in the first place income and purchase was significant? Was it a mistake on the part of statistical package, or is there something else?
Something else, not in the package.
Yeah, and the statistical package will not do any mistake. So there was something else. What was that?
Probably the variable which we considered was
So the
It's the level
education
of
and
education
Level
which
of
makes
education.
people to
huh.
use technology-based devices.
okay, no, that is fine. We understand that. But why in the first place income and purchase was positive or it was significant? If income is not a factor, education is a factor, then why in the first place income was so significantly associated? So
These
see,
devices are
income and
expensive.
education. Yeah. Yeah, go ahead, go ahead, go ahead. I want to hear from you.
These devices are expensive, so money to buy them.
Oh, logic understood. That's not my question. So, income
Because the
and
person who
education.
are having because the persons who are having income, good income, they are able to have enough education.
Oh, okay. So, just change it. The people with good education was able to having good income, right? So education actually supports income, right?
Income.
Education supports
Yes.
income, and there is an underlying relationship between income and education.
Yeah,
So,
yeah.
yeah, so the relationship between income and purchase was a replica of the relationship between education and purchase. Actually, with these two are underlying variable. You
So,
got the
so we
point?
are trying to say, so if we can buy education, we can buy goods, better goods. This is what we're trying to say. So one who can afford education, college education, can also afford to buy devices. This is what is the meaning.
Yeah, education leads to income and income leads to purchase. Very good. Yeah, that's right. Okay, thank you so much. Yeah, I'm done.
Thank you so much, sir, and thank you so much for enlightening us about dummy variables under regression analysis, and especially the last example which you have just given us. So it was quite a relatable example also, and yes, thank you so much. And to give vote of thanks, I would like to invite our program coordinator, Dr. Sachin Mittal, to give vote of thanks to Pankaj sir. Over to you, Sachin sir.
Thank you very much, ma'am. Uh, Before we conclude the session and present the vote of thanks, any participant has any view about the session, if you would like to share, the forum is open. If anybody want to say anything about the session or you have the query, then you can ask any question or any view about the session. If you want to share, you can. No one. Okay. So first I would like to summarize the session which has been taken by Dr. Prabhat Pankaj. Sir, in the first session has introduced to SPSS, in which he has explained how to import the data, then how to labeling the columns for the appropriate analysis. Then sir has explained the concept of mathematical modeling. Then sir further explain about the statistical modeling with error term, then regression, why regression has to be applied, when it has to be applied, how to apply in SPSS, then not only how to apply, the step-by-step interpretation of all the SPSS output sheet has been explained by the sir. Then in second session, sir has explained about the multiple regression, normality test, about the heteroscedasticity as well as multicollinearity issues has been explained by the sir. And in the last third session, sir has explained in detail about the dummy variable, why dummy variable has to be applied, how to analyze differential dummy variable, how to interpret the result. So I think as per the schedule, as per the suggested title, sir has explained and covered each and everything. I'm hoping all the participants are really learned and enjoyed this session. And I hope really now our understanding about the regression as well as the SPSS is now much better. And finally, as this is the training of the trainers, I hope this final benefit will be in future transferred to students, and students learning would be better in future. On behalf of IBMR IPS Academy, on behalf of all the participants and on behalf of AICTE, we really thank you very much, Prabhat sir. We can understand you are a very senior person and you are the director of one of the reputed institute. So it's not easy for you to spare the time, but on our simple request, we can see that you have a zeal that you want to share the knowledge, you want to spread the knowledge. So thank you very much for your this eagerness to share this knowledge. We can see that the full day dedicatedly you have share your knowledge, you have shared your time with us. And another thing that we have understand from these sessions, through this technology, the way you have explained all that concept, we can see your PPT handwritten papers you have converted into PPT form and step-by-step process you have explained. Thank you very much, sir, from the bottom of heart. And we hope that again in future, this association would be continue and we will invite you again in second phase as well as in the third phase, of course, subject to condition, your availability and if you can spare the time, we will happy if you allow us to invite you again in future. Thank you very much.
Absolutely. Absolutely. Thank you, everyone. Thank you, participants. And thank you, Sachinji, for inviting me. It's a cause of academics, and I'm always available whenever I find time. Here in my institute, I also teach courses. So it's not that I'm away from the academics. So I have designed new courses like happiness and well-being. I'm teaching economic history of India. I also take sessions in research. So, I have shared my WhatsApp number. If any of you interested in asking some more questions or getting in touch with us, feel free. Thank you. Thank you so much.
Thank you very much. The participants' feedback link is shared with you. So kindly
sorry, Sachin sir, I'm interrupting you.
Yes, sir. Yes, sir. Go ahead.
Thank you so much, Prabhat sir. Sorry, I haven't interacted in the morning. I was just occupied. So thanks for sparing your valuable time, Prabhat sir. And it was really very nice after a long, long time. I'm not able to interact, but yes, as far as the faculty members is concerned and this very important STTP, you spared time for this STTP. Thank you very much, Prabhat.
Thank you, Dr. Vivek. Thank you so much. My pleasure.
Thank you so much, sir, once again. Pankaj sir, Vivek sir, and Sachin sir, thank you so much. And again, I want to thanks to all the interactive participations for today, and we saw more of a interaction. That's what sir expected from the morning. So thanks to all the participants for today, and we are going to start tomorrow's session sharp at 10 a.m.
Thank you.
And one more announcement I would like to make regarding tomorrow's sessions for the participants. Tomorrow we are going to have a session on financial modeling using advanced Excel by Dr. Sachin Mittal, and also we'll have a knowledge sharing by industry professional Mr. Pranivesh Chatterjee, and he is going to share insight on using R for portfolio management. So participants, we are going to have a, we are going to start session tomorrow sharp at 10. And yes, and we wish you a, happy learning tomorrow as well. Yeah.
Thank you, Dr. Deepthi. With your permission, can I now stop my video?
Please. Yes, sure, sir. Thank you so much.
Thank you, sir.
Dear participants, it's a sincere request. Please log in on the time. We after a 10 to 15 minute, we have decided, because this is a feedback from the resource person, they would not be happy once the session is start. On that time, participants are normally less, but the end of the session, most of the participants are joining. Therefore, of course, we will wait for the 10 to 15 minutes, but after 15 minutes, we will log the meetings. So it is a sincere request. Please log in on the time. Thank you very much.